ladies and gentlemen, let's take a look at lesson 7.4. We're going to show that triangles are similar using side, 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 and side, angle, side. So once again, we're looking at things very similar to what we did in chapter 5, only we're not necessarily going to show that our sides are congruent anymore. We're going to start making sure that they're proportional. We're going to make sure they have those equal ratios. So let's take a look at what these mean in terms of the wording. So the side, side, side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. So the difference here is if I am proportional, then I make similar triangles. I can have similar triangles. So what does it mean to be proportional? Well, that means if FG is written in a ratio of A, B, and if GH is written in a ratio with BC, and if FH is written in a ratio with AC or CA, and all of those ratios are equal, then I know that the triangles A, B, C is similar to triangle FGH. That's all it means in terms of words. But notice we're not saying that the sides are equal. What we're saying is that the ratio of those sides are equal to each other. So what does it mean to use this? We're going to determine whether the sides, whether the triangles are similar. If they're similar, then we're going to write the similarity statement and find the scale factor of B to A. So we want to make sure we're going in that order, from B to A, from right to left. So let's take a look at that. We're going to match up SU. And if we notice, SU is the largest side in the B triangle, and we're going to match that up to PR. So that is 6/12. And simplify that, guys. Make sure you get it down. And because we want a scale factor, we want to keep it as a ratio, so let's turn 6 divided by 12 into the fraction 1/2. I'm then going to take UT as the next one, and that's the middle length. So I'm going to match that up with the middle length here, which is 10. So UT goes to RQ, which means I have 5/10, and 5/10 is 1/2. And then we're going to take a look at TS, which is my smallest side, and I'm going to match that up to the smallest side here, QP. And so 4/8 is equal to 1/2. So because all three ratios are equal, remember that's what we're looking for, three equal fractions, 1/2, 1/2, and 1/2. That means the corresponding sides of the triangles are what we call proportional. And so remember from our theorem, because we have three sides that are all proportional, that the triangles are similar. So we're going to write our similarity statements of PQR is similar to triangle SDU. Now they ask for the scale factor of B to A. Well, because we set our ratios up with the B over the A. This was the B triangle side over the A triangle side, and we did that for all three of them. I know that my scale factor is 1/2. All right, let's take a look at our follow-up. In example 1, what is the scale factor of triangle A to triangle B? We will discuss in class and see if we can figure that out. But I want you guys to write down what you think the scale factor from this previous example is if we're going from A this time to B. All right, now we're going to take a look at using this. How can we use it? We're going to decide whether the triangles are similar. So is triangle DEF or GHI similar to ABC? So we're going to have to set up a couple of sets of ratios. So first I'm going to set up a ratio with DEF, with that middle triangle up there. So I need to set up the ratios of corresponding sides. So they take us from the shortest to the longest, and then that remaining, this is kind of the middle side, that middle number. So I've got DE is the shortest side, and I need to match it up with the shortest side here, which is AB. So DE is equal to 4/6. Simplify that fraction down to 2/3. And if we need to, we'll once again model that on the document camera in class, or you're going to need to bring your calculator up so we can go over it one-on-one. But you should be able to simplify the fraction 4/6 down to 2/3. And now says to take the longest side. So if I look at the longest side here is 8, so 8, and then we take the longest side over here is 12. Both of those can be divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So we've got 2/3 and 2/3 and looking good. Now take the remaining side, that middle side. So EF is 6 and BC is 9. Each of these can be divided by 3. 6 divided by 3 is 2 and 9 divided by 3 is 3. So if we look, all three of the ratios are equal. So all three of the ratios equal 2/3. So that means triangle ABC is similar to triangle DEF. All right? So we're going to start this whole process over, and this time use triangle GHJ. So I'm going to do the same thing again. Start with the ratio of the shortest sides. The shortest side in GHJ is GH, and that's 6. AB is still the shortest side here, so that's 6. We're going to take a look at GJ, which is the middle side here, or the longest side, I'm sorry, and that's 14. CA is still the longest side here, which is 12. 6 over 6 simplified down to 1 over 1. 12 over 12, though, each of those can be, or 14 over 12, each of those can be divided by 2. So that's 7 over 6. I'm noticing I already don't have equal ratios, but we're going to set up the third one. The middle side is HJ, which is 10. And the middle side here is BC, which is 9. 10 over 9 doesn't even reduce, so if we look, we have two different ratios for the first two, and then a third ratio for the third set of corresponding sides. So because the ratios are not equal, so that's the equal sign with a line through it, triangles ABC and triangles GHJ are not similar. All right, so now we see what it looks like when they are similar. They all reduce down to the same fraction. When they're not similar, they don't. We don't have all three ratios equaling the same fraction. All right, so for your checkpoint, are they similar? And then write a similarity statement. So you guys are going to do math, and this we will check in class. So I'll bring one of you up to the board, and you'll share that with us. All right, so let's take a look at the next theorem, and that's side angle side. So if an angle of one triangle is congruent to an angle of a second triangle, so if we look here, we have angle X congruent to angle M, and the lengths of the sides that include that angle, so the ones that surround that angle are proportional, then the triangles are going to be similar. So what does that mean in words? Well, if angle X is congruent to angle M, that's what we saw, and then PM is with a ratio of ZX, if that ratio equals the other included side, MN, over the ratio of XY, so we notice the red and blue sides circle around, they include, they close in, they corner the green angle. If those are the two sets of corresponding sides that are equal ratios, then triangle XYZ is similar to triangle MNP. So now what we're doing is, instead of just looking at two angles or all three sides, we're going to look at one specific angle and then two very specific sides. So let's take a look at using this. Determine whether the two triangles are similar. Well, we see that angle C and angle F are both 61 degrees, so we know that angle C is congruent to angle F. So we have these corresponding congruent angles. So now I need to compare the ratios of those sides. So I need to compare BC, which is the bottom of the 61-degree angle here, and EF. I need to compare those. And then I'm going to need to compare AC and DF, the other side, that's the top of the 61-degree angle. They tell you to start with the shorter sides. It really doesn't matter. But if we take a look, we're going to put DF, the shorter side, over AC. That equals 5/3. Now 5/3 does not simplify, so that's our final fraction. If we take a look at the longer sides, we have EF over BC. That's 10/6. Each of those can be divided by 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. And so we do have the included sides having the equal ratios. So since the lengths of the sides that include angle C and angle F are proportional, that's the word we're using when we have equal ratios, are proportional, then we know that the two triangles are similar. So we can use our side angle side similarity theorem to say that triangle ABC is similar to triangle. We need to match things up. A went to D, B went to E, and we can see that C was congruent to F. Once again, we're going to take a look at these overlapping triangles and see what we do here. So we're trying to show that they are similar. So we're going to try and set up ratios with corresponding sides and show that we have a congruent angle. So I'm going to take a look at VWX, and I'm going to draw VWX. Label what I know. This is 4, and this is 5. And then I'm going to draw VYZ. Now you need to be careful when you draw these, ladies and gentlemen. Not just for that, but you need to make sure that you're getting the right side measurements. This side here is 4 and 8 together for a length of 12. This side over here is 5 and 10 together for a length of 15. So those are the actual measurements that you're writing down. So if we take a look, each triangle has angle V. So we can mark angle V as being congruent. That's the reflexive property when it's the shared angle. So angle V is congruent to angle V. Now I'm going to set up a ratio with the shorter sides. So I'm going to have VW set up in a ratio of VY, and that's equal with a ratio of 4 to 12. Each of those can be divided by 4, so 4 divided by 4 is 1, and 12 divided by 4 is 3. I now need to go over to the other side of my triangle and set up the longer sides. So VX, the longer side, and notice they both make up the sides of the marked angle. And that has to be set up in a ratio with VZ. I have 5/15. Each of those can be divided by 5. So 5 divided by 5 is 1. And 15 divided by 5 is 3. So since the lengths of the sides that include angle V are proportional, then we know that the two triangles are similar because we have an angle and two sides. So we would say triangle VYZ is similar to triangle VWX. All right, so let's take a look at our checkpoints. We're going to do the first one together. We can see that we have an equal angle with this 90-degree angle. So now I need to set up those included sides. So I'm going to take the smaller side, GH, and put it with the smaller side, LM. That's 8/6. Each of those can be divided by 2. And so 8 divided by 2 is 4. 6 divided by 2 is 3. I'm now going to take the longer side, which is HJ, and MN. That's 12 for 8. Now each of those can be divided by 4, and 12 divided by 4 is 3. 8 divided by 4 is 2. These are not equal sides, so we simply say no, they are not similar. And so your job is to do now, and then we will check in class. Remember, this is going to look very similar to what we just did in example 4. So you're going to take a look at example 4 to help you out with number 3. That is it for today. We'll see you tomorrow in class.